Hello guys, so many of you guys are going to be very happy now that you do not have to make tables to actually find limits. What we're going to be doing is going over very basic rules of and properties of limits today. It's going to make things a lot nicer. This is a longer lesson. The book breaks up this into very small chunks, and I'm used to kind of going all at it at once, but what's going to happen is we're going to go with small chunks. So some of these steps are going to be very small. Some of them are going to look similar, but what's going to happen in the very end is you guys are going to be able to put it all together. So I'm going to break this up into two parts. We're going to do examples 1 through 8 and checkpoints 1 through 8, and then afterwards you guys are going to see the next set. So what I wanted to do is go ahead and start this off right away. The first thing you guys should notice when we're looking at this is this reads the limit as x approaches 4 of 7. 7, this is a constant function. This is a constant. Okay, what this graph would look like is you'd have your y value 7, and this right here, this line going back and forth would be the graph of 7. So find the following limit. So if we plug in x equals 4 here, what would my y value be? It would be 7. Okay. The next idea is the same. We're now taking the limit as x approaches 0 of -5, and what do you guys get? Well, you get -5. Once again, why is this the case? This is a graph at -5, or the function is at -5, and you guys are going to be plugging in 0 for x, and you're going to find that your y value is still -5. Okay, I'd like you guys please do checkpoint 1 for me. I'm going to go ahead and give you guys a moment. All right, the next part, what's going to happen is we're going to go on to example 2. The idea of this now is when we're taking our function and plugging in a value for it, we're going to be able to find these. These are all just very basic kind of lines. So essentially we have our function right here. We have y equals x. This is y equals x. So if we were to plug in 7, what would our y value be? Well, in this case, it would also be 7. Okay. Following that same sort of idea, if we take this, we're starting to see that if we're taking this limit, we're able to just go ahead and take it and substitute it in for x. So if I take -pi and plug it in, I'm going to get -pi. Okay. As we start adding more functions to our repertoire, this is going to be a little different, but as we're starting, it's really just going to be something where we're going to be substituting our value, and if it gives us a value for it, that's going to be our limit. If there are some special cases, we're going to be going over those in 9 through 12. Okay, so go ahead and take a moment and finish off checkpoint 2 for me. All right, so here's where we're going to go over a couple of the properties of limits. So how do we find a limit of a sum, such as the limit of x as x approaches 5 of x plus 7? Well, if you take each of these portions individually, we know that if we take this part, we're just going to be plugging 5 in for x, and we're going to get 5. If we do that for the limit as x approaches 5 of 7, we're just going to get 7. So we're going to add those two together, and we're going to get 12. So the idea is you can break these apart into smaller portions and then add them back together. Okay, so what we're going to do is on example 3, same sort of idea applies. We're able to take this -4 and we're able to substitute it in here, and we're going to get -4 plus 9 equals 5, and we just found our limit. What I want you guys to do is go ahead and do the same exact thing on checkpoint 3. All right, we're going to do the same sort of thing for a difference, okay? So finding the limit of a difference, we're going to go ahead and take this 5 and substitute it in, and we're going to find that we get 12 minus 5, which is 7. So a lot of people are probably going to say, Mr. Lee, what does this have to do, or how is this different from just substituting in an x value? Well, there are cases that you guys have seen from our last lesson where your function, it's not just going to be a line. This function, however, is a line. We're starting off at 12. This is 12. And then we're losing x. And then at 12, we're actually going to touch here. So it's going to go and it's going to look something like this. So this is going to be your function. And essentially, when you're looking at it at 5, it's asking you at 5, what specifically is happening here? Okay, so it's asking what value will that actually be at. So if we take our limit from the left and our limit from the right, those two limits must be equal to one another. Since this function's defined there, it's very easy. But what we're getting to and what we will be getting to is what happens if it's not defined at that point. What happens, that didn't work out the right way. What happens if we are going and taking this and the function has a hole here? What would the differences be? Would our limit still be that? Will it still be 7 there? What happens if our function's piecewise and it starts to break apart? So instead of having this, if we were to have a case that looks more like this, where we have our hole and then it's defined all the way up here, what would our limit be? Would we have a limit there? Why? Why not? So there are different instances where we have to think through it. Once again, we're starting out with the very basics as we're going through this first portion. Okay, now we're going to be talking about something just a little different. We're going to be talking about the limit of a product. Okay, and essentially, when you take the limit of function f and it gives you L, and of function g and you get m, then when you have that that portion where you're multiplying them by one another, you're able to split it up and then multiply your two products at the very end. So when we're looking at this first one, essentially, we're going to go ahead and think about it, and we're going to come back to it and see if we could just substitute once again. So this is taking the limit as x approaches 5 of -6 times the limit as x approaches 5 of x. Okay, if we go ahead and we take this, we're going to find that this is 6 and this is 5, so we're going to get 30, -30. So would that be the same exact thing as if we just substitute this 5 right here in for x? Well, 5 times -6 is going to give us -30. So that idea still applies. So what I want you guys to do is go ahead and plug in and do the same exact thing for checkpoint 5 for me, please. All right. So now we're going to be taking and putting all of these properties together, and then we're going to introduce division when we're doing this as well, where we run into some special cases, like where we have sine of x over x, and we're taking the limit as x approaches 0. This is going to be one of those cases where it's undefined 0, so what do we do to find that limit? Is there a way to do it without making the graph? That's what we're going to be going over in just a little bit. So right now, we're going to take our same ideas, and essentially we found that we're able to just substitute this number in, and if it gives us anything but undefined, that will be our limit. Okay, especially because this is a line, we know it's not going to have any points where it's undefined at. So we're going to have 7 times -3 minus 4, and we get -21 minus 4, which is -25. So that works out just fine. Same thing over here, we're going to take 5 and substitute it for x, and we're going to get 6 times 5 quantity squared, and we're going to get 6 times 25, which is 150. So it works out just fine. I'd like you guys to go ahead and please do checkpoint 6 for me. All right, for the next part, it says finding the limit of a monomial. It's the same sort of idea. Except for we only have one term. So with this, we're going to take and we're going to substitute this 2 in here. And once again, what this means is we're finding the limit from the left and the limit from the right, and we're seeing what happens. And essentially, when it's a monomial or anything we've gone over so far, substitution works. In this case, it's going to be very similar, except for we have x to the power 4 in this case. So we're going to have -6 times 2 to the power of 4. And when we do this, we're going to have -6 times, what is that, 16? And -6 times 16, we're going to get 36, 96, -96. I'd like you guys to please go ahead and do checkpoint 7 for me, please. All right, now we're going to talk about the limit of a polynomial, okay? So when we're doing this, we're actually going to be able to break it apart into 4 parts. But as you guys have seen so far, we're able to just take this value, substitute it in. As long as the function is defined, then we're able to go ahead and do this. Okay, so when we do this, we're going to have 4 times 3 to the power of 3 plus 2 times 3 squared minus 6 times 3 plus 5. Okay, and when we do this, we're going to get 4 times 27 plus 2 times 9 minus 18 plus 5. And when we do this, we're going to get, what is that, 28, 108 plus 18 minus 18 plus 5. And when we do this, the 18s cancel, and we're going to be left with 113. So I'm going to go ahead and break this off into another section so this video is not a forever long video. Please go ahead and do checkpoint 8. Don't forget to submit at least one of your checkpoints, a picture of it, so I can give you credit for taking the notes. Thank you very much.